Hello and welcome back to Calculus1. Guys, this section is extremely important for your future because this is how you make money. So most of your contracting jobs are right here in this section. Let's see. So we start by first understanding the concept. Optimization, meaning you are looking for maximum, you're looking for minimum value of the function. That is what you're looking for. Now, how do you get the minimum maximum values? You find the function, take derivative, set it to 0, right? So that's the same procedure as we did in two sections prior to this one. So to find min and max, you will have to set equation equal to 0. But you are going actually to see that we are not going to set it equal to 0 from the derivative procedure. We're going to get that 0 just show up, right? So what I want to do now is I want to explore a question just to kind of learn a little bit about procedure. So what two positive numbers which add to uh, 16 have maximum product. So which two positive numbers which add to 16 have maximum product? Come on. 8. So yeah, you can guess, right? You can guess this question. You can go 1 times 15, right, because that adds to 16 is 15. 2 times 14 is 28. 3 times 13 is 39. 4 times 12 is 48. 5 times 11 is 55. 6 times 10 is 60. 7 times 9 is 63. So see, it's getting better, right? And then 8 times 8, 64. And then 9 times 7, right? So by inspection, we were able to figure out that actually numbers are 8 and 8. But can we figure out that using calculus? And the answer is yes, because we can write mathematical equations. When we read English sentences, we write mathematical sentences, which are called equations. So they're asking us to add two numbers to 16. Well, common sense, x plus y is 16. I mean, there's nothing else you can write if you're adding two numbers. And look what they want. They want the product of these two numbers to be maximum. You see? So this is how you model in mathematics. You're sitting in a business meeting, right? And people are telling you what they want, and you are translating their words into equations which eventually become concepts, right? And so on. So the problem clearly stated that two positive numbers are to add to 16. That's x plus y equals 16. And the product of those two numbers needs to be maximum. So there it is. I wrote everything down. And now I know that I'm optimizing this formula here, which means I'll be taking derivative of it. The problem is I have two variables. So I'm going to use constraint equation to solve for, let's say, y as 16 minus x, and I'm going to plug that in objective equation, which is the one that has min or max in it. So now y is replaced with 16 minus x and distributed. And observe that your entire equation now is only in variable x. This is when you hit that equation with the derivative. Now guys, this is the key. Derivative of 16x is 16 minus 2x equal to, what's the derivative of a max? Derivative of a max must be 0. Because what is max? Max is the maximum product. In this case, the 64. Derivative of 64 is 0. We don't know that it's 64, but it is some number. And the derivative of that is 0. So now, whether you remembered that you are supposed to set derivative to 0, or if you are understanding calculus enough at the moment, you know that max is a value, and when you take the derivative of it, is 0. You can clearly see from here that x equals 8, right? Because move 2x divided by 2 both sides, right? And then you bring that 8 back up there. So y is 16 minus 8, and you get another 8. And you say two numbers are 8 and 8. It's the same number, right? 8 and 8. For the maximum, right? The procedure that you've seen right now, it doesn't matter how complicated the problem is. The procedure that you see right now is going to be standard from problem to problem. What's going to be different? Modeling. Getting the equations, the concepts around it is different. But the procedure is the same. You write two equations, plug one into another to eliminate a variable, and then derivative, and you will have one of the numbers. Then calculate the other one, and you're done. So let's take a look at some of the examples that we can solve with this. There is a lot of really cool stuff that you can do with this, and then depending on how interested you are to actually pursue and do the trig and angles and everything else that can be done. So here is the question. Minimum perimeter of a rectangle. So of all rectangles of area 100, which one is the one with the minimum perimeter? Problem number 7. So of all rectangles with perimeter equal, no, area equal 100, which one has the minimum perimeter? We should clearly write some equations, right? You draw the rectangle, and you have your x and a y. What's the area equation to utilize 100? X times y equals 100. Very good. And it says which one has a minimum perimeter. What's the perimeter? Very good. Equals to minimum. Very good. So here's your constraint. And here is your, on the bottom, objective. So what do? We take the constraint and we say y is equal to 100 over x, right? And then we plug in. So we get 2x plus 2 times 100 over x equals a min. So that's 2x plus 200 over x equals a min. And look, the entire equation is simplified, and it only has one variable, which means it's ready for us to hit it with a derivative. What's the derivative of 2x? 0. Plus, what's the derivative here?
Negative 200 divided by x squared.
Very good. Negative 200 divided by x squared equal to?
0.
0. Because the derivative of a minimum, which is a constant, is 0. That minimum is the perimeter, which is maybe 17, maybe 207, I don't know. Solve this equation. So move the other side, right? And then 2x squared is equal to 200. X squared equal to 100. X equals 10. So what we got? 10, 10. So what is the rectangle that gives us the minimum perimeter? It's a square 10 by 10. So those were the preliminary exercises. Now let's see how this relates to stuff out there. So the most famous are farmer problems. Where the farmer has certain amount of fence and he wants to fence off a rectangular area, pasture or whatever, right? And what is the maximum area that can be fenced off and so on. So let's take a look at, say, farmer has 2,000 yards of fence. Find the dimensions of the plot of max area that can be fenced off. So what are the dimensions, right? You immediately say, well, he is talking about the rectangular plot of land. You know that the perimeter is where the perimeter fence goes. That's why it's called perimeter fence, right? So we have 2x plus 2y is equal to 2,000 yards, which you can immediately simplify into x plus y is 1,000. And you also know that you want your xy to be a max. Guys, isn't this the same as the first problem, except over here you have, over there we had 16, over here we have 1,000? It's the same problem.
Are they all going to be like pretty similar formatting? Just different?
They are all the same formatting. It's just depending on which equations you're using. The procedure is the same. So over here, y is 1,000 minus x. Plug in. We have x times 1,000 minus x equals to the max. 1,000x minus x squared equals to a max. Hit that with a derivative, and we're done. 1,000 minus 2x equals 0. X is 500, and then eventually y is 500. So dimensions are 500 by 500 yards. The units are going to be, there will be points assigned to units. So this problem is the same. Let's modify the problem. Let's make it better. Here's river. All right. And then we have the plot of land right there. Observe that there is no fence towards the river. So you just have a y, y, and x. Does this change situation?
Yes.
How?
1x.
Where?
The
Perimeter. Very good. So now perimeter is x plus 2y equals 2,000. So now we can clearly fence off bigger area, right? Because we don't have to use fence for one of the sides. That leaves more fence for our other three sides. And we still have xy needs to be a max. So if you look at this problem now, you already have x is equal to 2,000 minus 2y. You plug in. It's always the same procedure. As soon as you have your constraint equation and the objective equation is the one that has min and max in it, you can flip the constraint equation to get the variables, to cancel the variable, right? So now what I have is 2000 minus 2y times 1000 equals a max. And then what I have is 2000y minus 2y squared equals a max. And then we differentiate in respect to y this time, because you are maximizing y in this equation. That's a 2000 minus 4y equals 0. So how much is y? Very good. And x must be 1000. When you bring back 500y in this equation here, 2 times 500 is 1000, 2000 minus, right? So from here to here we said x is equal to 2000 minus 2y, and we know that y is 500. So what are the dimensions now? 1000 by 500 yards.
Save that. I'll take this any day.
How about if we need 3 bins? You want to put cabbage, tigers, and rabbits.
That makes sense.
You can't put all of that in the same bin, right?
When the rabbits just try to eat the cabbage?
Yeah, exactly. That's why we separate them, right?
So now we gotta figure out the fence.
Exactly. That's why we separate tigers as well. So rabbits separate from,
Hey, they could be good friends.
right? Rabbits separate from tigers. Rabbits separate from cabbage.
So we gotta figure out.
You also separate tigers and cabbage too. You're gonna pee all over the cabbage.
So we gotta figure out the fencing now.
Yep. How many y's do I have here? See that? So guys, you have to look at the geometry, because geometry, the picture over there, is going to tell you what the equation is. So we are modifying the equation now. You're going to have 2x's plus 4y's. You still have your 2000 yards of fence, right? It's the same farmer, same fence. And you still have xy to be a max, right? And now when you compute, the calculation is absolutely the same, right? So I want you to calculate this. Divide top equation obviously by 2 to make numbers smaller, because you can. And then plug everything in and be done. So let's see. And then we're going to do something more interesting.
I'm not paying attention. Just Brian and the teacher. Alright, I'm gonna go. Oh, why did I pop my head now? What thought? I'm gonna relax a little bit. Now we're gonna Friday. It's gonna hit it hard.
You realize in 2 weeks, in 2 weeks and 1 hour from now, not even 1 hour, no, now, it's 7 o'clock, when your final is 5 to 7. So in 2 weeks and 10 minutes. Okay.
Yes, we do.
2 weeks and 10 minutes, you can do whatever else you want.
It's not good to relax a little bit.
Actually, that's not entirely true, because your homework is open till the midnight of the day of the final. So you can still, after the final, go home and do more homework. Yeah, so let's say you have few sections that are 0, right? You can't hand in anything on paper because you won't see me, but if you have my math lab, you technically can be improving your grade all the way till midnight. So So that's additional 5 hours after the final.
How much is total?
If you 10%. So that's a whole grade.
But I thought you said when you do the homework that if you just check to see if we did something versus like.
Exactly, but I said if you have a 0, let's say you have 4.30, right? And then let's say 4.3, 4.4, and 4.5 are all 0. You have still 5 hours
So
after the final.
basically, all you have to do is one problem to get credit.
What?
Beating the system over there. All right, what's the answer over here?
Y equals 250, X equals 500.
500 by 250 yards. Great. We can go crazy with this as long as you know geometry and know how to figure things out. You should be fine. So you can have like this and then put, right, something like that. It's okay. The whole thing is x, the whole thing is x, the whole thing is y, the whole thing is y. This little thing is y over 2, and this little thing is... you add them all. You just add them all. And you just have a crazy numbers to work with, but the procedure is still the same. You will still have the two equations. You want to make it worse? That's fine. You can go like this and say halfway here, let's say, and a halfway here, do the diagonal. It doesn't matter, because this over here, you know that this is y over 2, and you know this is x over 2, so use the Pythagorean theorem to figure out that length. You know, there's a lot of stuff that geometries that you can work with, and optimization is figure out two equations, constraint and objective. Objective is the one that has min and max in it. Now let's take a look at shipping crates. So shipping crates, you understand that a shipping crate or a suitcase is a box. All right, so think of a box. You're going to vacation, you put all of your clothes and stuff in a box. So box has dimensions x, y, z. Now 3 variables is the deal for Calc 3, not Calc 1. So in order for us to solve some of these problems, we work with, we say that the box is to have a square base, because that eliminates one of the variables, right? So that will make x and a y both be x, and then you just have a y as a... So we're going to deal with this in Calc 3. So what we want to do here is the box. So for Calc 1 is the box with square base. Now every time I teach Calculus 1 class, I challenge students, and especially now for you guys, the weekend is coming up, to take a piece of paper, regular printing paper, right, 8 by 11, or 8.5 by 11, whatever the hell it is, and create, first calculate, and then actually make the box with the largest volume. So you have the dimensions of a paper. You know it has to be square base, which means you first have to trim the paper to be square, largest square you can make, and then calculate the largest possible base. So now how would you do that? Right? You have a square paper. Oh, and there will be no top in this case, because that would take a lot of material to actually make. So if you look at the picture, what you need to create is a cutout like this of the paper, right, where you're cutting off these corners, and then you just bend these, and you can use tape, and you can decorate with glitter and stuff, whatever you want to do. You can bring in.
Oh, the box.
So my question is, you have the dimensions of the paper, right? You want the max volume. So now when you label this as the X and you label the height as Y, right? When you look at the box sideways, you see that the base has X and the height is Y. So what's the volume equation for this one? Very good. X squared times Y. So X squared Y is equal to a max. And now I gave you some values, right? You know how much is this dimension, because that's the width of the paper. So you can express these x's. So I would like you to kind of try this, and then if you don't have it by Monday, I will work out this exercise. But I want you to try and figure out the constraint equation, because this little piece over here is y, right? Those are the heights. So you have the y's and the x, and you have the dimension of the. So you should be able to figure it out. So try this, and if you calculate, make the box. Take the piece of paper and make it. And that's where your engineering starts. Now, this part is the part of packaging engineering, which is a very hot topic now at Rutgers. I heard a lot of reports that students are getting jobs before they even graduate, because. Well, you can call it like that, but you have to understand that the pencil you're holding is made somewhere else and needs to be shipped here. Yeah, and then it goes for car and a projector and your glasses and your clothes and everything that you see around you. Yeah. We make movies and corn and what else?
I'm not saying making boxes is a bad thing.
Oh yeah, Elon Musk is making Tesla here. Yeah, exactly. Everything else is not here. They're all in Mexico. All the plants shut down and moved to Mexico. Yeah, it's 50 cents per hour for a worker in Mexico to make. Yeah, that's called outsourcing. That was Bill Clinton. All right, guys.
Thanks,
Where are you going, Luke? Where are you going,
Devoured. The next problem. Let's see. Something cool. Something really cool. Oh, here's this. How about some of the minimum distance? So, find problem 20. Find the point. Find the coordinates of the point. So find the point P on y equal x squared that is closest to 18, 0. So when you are looking at this problem, right, it doesn't look like particularly interesting or important problem, right? But it's actually insanely important, because it's how you trace things. You want to write a computer code that traces things? You are talking about this distance here. You want this distance to be the minimum. Here's your 18, 0, and here is your unknown xy that you need to figure out. How would you go about solving this problem? What do you do? Nope. Very good. What is the formula?
Square root of x2 plus x1, or minus x1 squared, and same thing for the 1.
Very good. So we have a distance formula, and we want that to be minimum. Look what you have. Your point number 1, which is the one that you're looking for, is x comma y. Your point number 2 is 18, 0. So you can go and say, so you have x squared minus x1. So let's go x2. So call this point number 2, call this point number 1. So you have your x2. So x minus 18 squared plus y minus 0 squared. And that distance you want to be minimum. There's your objective equation right off the bat. Right? And then we also have the constraint equation, which is y equal x squared. You can replace the y with x squared and FOIL everything out. So we're getting x squared minus 36x plus, what was 18 times 18 is 464, 324. And then plus x to the 4th, because you plug in x squared for y and then you square it, equals to a minimum. You see how this equation over here has only x's, and you can immediately hit this with a derivative, and you got your x. Now the derivative of this is, right? We have 2 times the square root goes in denominator. That's the form of how we take derivatives of square roots. Its derivative on top, which is 2x minus 36 plus 4x cubed, equals 0. You got to solve this equation. Is this easy or hard? Easy. Because when you cross multiply, denominator dies. It multiplies into 0, right? So all you worry about is 4x cubed plus 2x minus 36 equal to 0. But then this equation can factor out 2. So it's 2x cubed plus x minus 18 equals to 0. So this is equation that you need to factor and somehow solve. Now that's either going to be calculator or it's going to be the... you remember the rational zeros from pre-calc 1?
No.
You can do that. Yep. Factors of 18 divided by factors of 2. So factors of 18 are 1, plus minus 1, plus minus 2, plus minus 3, plus minus 6,
Oh, no, I don't remember.
plus minus 18 divided by plus minus 2, and then keep guessing the answers. Yeah, we can do that.
Wait.
Or you can just go to Mathematica and say,
No, that's the...
In that case, I'll look this up the test.
yeah, well, it's not good for the exam, but it's good.
The exam to use Mathematica.
Oh, I would vote for that any time. So solve 2x cubed minus, no, plus x minus 18 equals 0. We have 3 answers. 2 are complex, which we are going to ignore, and the 1 real answer, which is x equals to 2. Insert Wolfram. There we go. So now I have that x is equal to 2. And we know that y is x squared, so y is 4. And what is the point P? Point P is 2, 4. That's the point on the x squared graph that is closest to the 18, 0. Guys, these are your engineering problems. These are your things when you're building bridges, when you're designing GPS, when you're doing, this is what you do. And computers are not going to do this for you. If you are a business, you are going to see problems that you can get contracted for to make a ton of money because you save companies a ton of money. Optimizing means minimum cost, maximum profit. And you are able to compute those things. If I'm working on the cost of the pipeline, which is usually a problem that I like to work out, which takes forever to compute, you can see how much money you can save to a company.
So wouldn't that mean that there were like easy years ago that a bunch of people already made sub-programs that already do all this stuff and find all the values?
Yes.
So that you can do that and then move on to the problem where it's your job to do like a actual designing instead of doing that.
Mm-hmm. So that's the, much of this is already done, but then again, you need to be able to tailor this to your situation. So now the last problem that I want to take a look is the business problem. I don't think I'll have time to actually finish it off, but you can at least take a look at how it looks like and then follow the same math like for this problem here, except with crazy numbers. So this is what we are considering. We're considering a shoreline here. So this is shore, and this is sea. And it's the oil rig over here. And that oil rig is close to the, it's close to the shore. So you're not going to have tankers go back and forth, back and forth. You're just going to build a pipeline. And the place that refines is right here. So now you have choices. Use the cheap pipeline along the shore because it's built on ground, and then expensive pipeline for the shortest distance underwater, which is expensive to build because you're building pipeline under the water, and have one route done like that. You can also have a path that it's a direct pipeline. It's all underwater because it's the shortest distance, but it's the most expensive pipeline, right? Or you can have number 3, go for some time on ground and go through the water. So the first two are easy to compute. Say that the cost of 1 mile ground is $250,000 to build for the pipeline, and 1 mile underground is, let's say, $500,000, right? You can use these numbers to calculate if you know, let's say that this is, I don't know, 6 miles here and 8 miles here. Let's say that's how long, or 10, whatever. It doesn't really matter which numbers you pick. So let's say you have 6 miles out and 10 miles out. You have the black route, right? That was the first one we said. You go 10 miles up, so that's 10 times $250,000 plus 6 miles underwater, which is 6 times $500,000. Oh, I should have picked 8 because times a quarter, easier calculations. 8. So 8 miles times a quarter is going to be $2 million, plus 6 miles for $500,000 is $3 million. So it will cost you $5 million to make the pipeline if you use the black route. Now you want to use the blue route. Well, the blue route, we need to calculate that, that length over there, the distance, which is the Pythagorean theorem, right? So for this one, is going to be that is a square root of 8 squared plus 6 squared, which is 64 plus 36, so you get 10. Right? It's a 64 plus 36, right? It's 10. It's 100. So 10. So we have 10 miles distance. So the cost is going to be all underwater. So it's 10 miles times a $500,000.
So that's another 5 million.
It's another 5 million. The argument here is that the red one is cheaper. So this one should be cheapest. And the way we get this is we say, I don't know this distance x here. I don't know this distance x. But if I can figure out how far I have to go on the ground, the rest I build underwater, I will have the lowest cost. So what I do is I create, so I have the distance d underwater and the x is on the ground. And I say, all right, this part over here is 8 minus x, because the one on the bottom is x. So what do I have? I'm going to have the cost equation, which says x times a quarter plus d times a half needs to be minimum, because I'm minimizing cost. And this is how you make money, because you are able to figure out that there is an equation there that will give you a minimum cost, which is quarter of x plus quarter of d, because those are the half of d. And now we need also an equation that connects x and d, and that's a Pythagorean theorem up there, which says that x 8 minus x squared plus 6, right? So 8 minus x squared plus 6 squared is equal to d squared. That's your constraint. You can solve for x or d in that equation, plug it in the upper equation, and hit it with the derivative. You will calculate, right? So solve the one on the bottom, d is 64 minus 16x plus x squared plus 36, square root of that. That's your d. So d is equal to square root of 100 minus 16x plus x squared. And now you plug that in. And you have x over 4 plus 1/2. Instead of d, you have a square root of 100 minus 16x plus x squared equals a min. And this is where you hit derivative. You will calculate the value for x. As soon as you have calculate value for x, you bring it over here, calculate value for d, and that's how long. You can also calculate the cost. The cost will be less than 5 million. So if the cost is, let's say, I don't know, 700,000 less, it's nothing for a company to give you, you know, $30,000, $40,000 for 10 minutes of work. I know, because if you save them, you know, $500,000, it's nothing for them to give you 10,000 or 20 or 30 or 50,000 out of that, right? Because you can do that every time when they need the pipeline, when they need, right? Now it's the electrical cords, it's everything else, right? Cable on the, or underground.
If we use the rest of that money to pay people to do it.
No, you're the only one who does this. What do you mean?
People
Oh, let me just say, huh?
pipe.
No, that's included in a $250,000 cost. That's the cost of building pipeline is the actually cost of workers, and the cost is a cost. Everything is there.
Like insurance and whatnot, like I'd assume that the water would be a lot more dangerous, which means that
That's why it's $500,000 to
yeah,
build a
but
mile.
you'd have to include the chances versus
Yeah.
theoretical versus practical.